What?
Every time I go, because I used to be on a do not fly list. No, I went to like a shooting range with my family, and I actually brought like a round with me.
All right, Luca. I don't really care. Okay, so integration of certain things that you should already know. Let's talk about trigonometry and focus only on trigonometry only. So if I have integration of sine of x, what do you think that is?
Negative cosine.
Negative cosine of x. And the way I memorize this, the way I memorize this is I don't just memorize the integration and derivative separately. I memorize the derivative only. So I know derivative of cosine is going to give me negative sine. Therefore, integration of negative cosine, integration of sine of x equal to negative cosine of x. That's how I memorize. I remember one thing and I understand one thing and I react to the other thing due to associations. Right? So those are the things that what you need to learn is learn how to associate, connect the dots, so you don't have to use a lot of brain power when you think of something. So integration of cosine of x is what? Sine of x, because derivative sine of x equal to cosine of x. And that's okay. That's very, very easy. The tricky ones are actually this one. I think a lot of people thought is positive cosine of x because they do derivative sine of x equal to positive cosine of x, and that's why they don't know that's the negative sign. So the problem is that, so that's the first part, understanding. Lucas, can you put your computer away? Okay, so integration. Now the other one here is something kind of don't know. Any other trig function you know of, like integration of?
You don't know?
Yes. 10 of x.
Well, not 10 of x.
Sexy 10? Okay, secant of x, 10 of x, dx, good. So what derivative is going to give me sexy 10? Secant of x, right? So that's going to be secant of x plus c. So this one is like from the derivative rule that we learned in the past. And according to the same association, it's going to be cosecant of x and the cotan of x dx is equal to what? Negative cosecant of x plus c. So now that's due to association as well. So I know this one, I know the other one, I know the other one, I know the next one. So it's very, very easy. What's the next one? Secant square of x dx. Good job, Andrew. That's equal to 10 of x plus c. And the integration of cosecant of square of x dx. Negative cotangent of x plus c. Great. So you guys all understand. So can you tell me what's four missing trigonometry that you don't know about? There is another missing. Tangent of x. Good. So the first one is tangent of x. Of course, there's a cotangent of x. There's two more. Secant of x. And the cosecant of x. And you say, wait, how do I do those, right? So it turns out that you already know tangent of x, but you don't know, right? So it's one of those things that if I get this room together, I think within probably 8 minutes, you guys will figure out how to take integration of tangent of x. But I don't have 8 minutes to waste because I have 8 minutes to teach two integrals. So I'm going to teach you. So integration of tangent of x dx. Well, we already know trigonometry says that's the sine of x over cosine of x. Do you guys see it already?
Yeah.
What does u equal to? Cosine of x, but there was a missing pieces because du is equal to negative sine of x. Thank you. So negative sine of x dx. So then it's going to be integration of u. And this one is going to be du over negative sine of x. And this is sine of x. And they kind of just cancel out each other. And that's going to be negative du over u. And that's equal to negative cosine of x.
Wow. Natural log coming in. That's good to see.
Okay, so Now, next thing is due to association, you can probably know the next one. What's cotangent of x?
Cosine over sine.
I would say natural log of negative sine.
No, it's not negative sign.
Positives. Absolute value of sine plus c. It doesn't matter.
And why you don't have a negative this time? No.
Because it's the integral of cotangent. So cotangent.
No.
You said u equals sine.
Yeah, so Shira's right. Is when you said u equal to sine of x, du is going to be cosine of x. So you say, wait, that's positive. Yeah, it's positive. So that's why you got natural log of sine of x. Now, I want to give it to you, like I used to taught IB in Cyprus. So IB program, they use a British system. Now, if in case you go to school in Cambridge, I don't know anybody well, but this negative sign can change to up here to -1. So you can also write as natural log of secant of x, because that means 1 over cosine, right? So you can do negative power. -1 power is not the inverse, so it's going to be secant of x. So you can also write as natural log positive secant of x, absolute value plus c. But that's only if you're in the IB program and IB use that formula rather than this formula. I do like calculus formula better because it shows like just a very general same trend as the other one. Now, the problem is not this one. The problem is this one. Now, here's the thing. Like I said, one of my favorite classes in high school, you would think it's probably math, but it's not. My favorite class is actually European history. My teacher is great. My teacher is teaching Dr. Phillips, which is 10 minutes from here. His name is Mr. Herschel, and I still remember his name. He's like this the chubby dude. Like he like had like beard like this, and I remember like he knows all the backstory of like a lot of things. Like he knows a lot of things. I learned a lot of things in that class. And actually, funny thing is that he actually know all the sex scandal of any kings and queens. And it was lovely because he would know which one's lesbian, which one's gay, which one's pretend to be straight, and which one's pretended to be not. So it was a lot of interesting. And all like queen for England and how they have like boyfriend elsewhere. Like they would know, like he would actually know which boyfriend they have.
Is that creepy or cool?
Very, very cool. No. He just understand all the backstory. But I learned one thing in that class is one of the question always on European AP exam question is define Renaissance man. Do you guys know what's Renaissance man?
Yeah.
He's a man in the Renaissance.
No.
It's like a guy who puts this forward into like new thinking.
Well, not only that, multiple field of interest, right? They are like Da Vinci, right? He's a mathematician, he's an inventor, he's a musician, he's a astronomer, he's just philosopher. He gets all, like he understands everything. So in terms of if you only become a mathematician, you really have to be creative because a lot of great mathematicians like Pythagoras, Descartes, all those things I learned in European history, and I'll make a connection now. So it's actually really good. So I will say math is probably the most creative subject there is, because just think about this, is this. The things like the people that are able to come up integration of secant of x have to be super creative. They not only can think one step on the chess, they can think like 15 steps ahead of what things can happen. Because there's an infinite amount of choices here, but they choose to do this, okay? I want to show you what they choose to do. So the person invented, I don't even know who invented, I don't know who should get credit, but this is super intelligent. So he decided to multiply by something like this. And he multiplied by a 1. But we know 1 could be x over x, x squared over x squared, sine of x over sine of x, 10 to x over 10 of x. But he choose to be this particular one, which is blow your mind because infinite amount of choice, he choose this one. And just because he see things way ahead of everybody else, he's 2 steps ahead of everybody else.
What?
Yeah, what? That doesn't make sense. Why secant of x plus 10 of x? That absolutely doesn't make sense. But the person who invented, he says this is only way to do integration of secant of x. And you say, what? That's how that possibly, right? So what you're gonna do is we're gonna make the things look even more complicated now, and then all of a sudden just become clear. So that's what's so elegant about this. So integration of this, I'm gonna distribute that. So it'll be secant square of x plus secant of x tan of x over secant of x plus tan of x.
No,
Now, do you see something? It's pretty cool.
it's all the power. It's like the.
No, it's not a power. You are just thinking. You are just thinking with other things. You had to think with your brain.
It's the derivative of tangent and secant.
Exactly. U equal to secant of x plus tan of x. Du is equal to secant of x tan of x plus secant square of x dx. Now, what do you see? Du over secant of x tan of x plus secant square of x, and it is equal to dx. So therefore, integration of u on the bottom, this is secant square of x plus secant of x tan of x times 1 over secant of x tan of x plus secant square of x. Now what do you see?
They cancel out.
They kill each other. It's kind of violent, right? So therefore, that's going to be 1 over u du. And that's going to be natural log of secant of x plus tan of x. And that's it. Think about this. Who can come up with this, right?
Somebody with too much time.
No, it's not even time. This is not even time. It's like
Start at the end.
it's like a field vision of what you can see like very far away, right? You can actually imagine things happen before it happens. It's kind of like a very cool. So the funny thing is the integration of cosecant is going to be association as well. It's going to be negative natural log of CSC of x plus COT of x plus c. Literally, like this question is so cool. Like 1 year I taught this question to this kid, Louis. And Louis says, I ended the lesson like right before the bell ring and I finished a problem. He said, Mr. Ye, I'm going to be honest with you. I got totally turned on by this problem. So that's what exactly he said. It was a very funny quote. But I just want to share with you because that's really, really funny.
The problem is making me argue.
So anyway, so that it was a very interesting because it's like even a student who is that Louis is actually not good with math, but due to this question, he kind of appreciate a lot more, and it was very interesting, right? So a lot of times, like you got to think about math is actually not boring, it's not bad, it's very, 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 very creative, and this is one true example. And this is just one example. A lot of people think math is nothing, but think about blockchain. Think about cryptography. Think about all this thing. It's all due to mathematicians. Like code. What's that code? From Turing, Alan Turing.
Oh, I know what you're talking about.
Limitation game. He's a mathematician. His name's called Alan Turing. He's in British, and he helped England to break the code for.
It's the Turing machine. It was like the Germans. They created like this really complex encoding. Like each letter had its own encryption. So like every time you press the key, it's like a new encryption.
Yeah, and that's super cool because the German will send a message to Italy and to Japan saying how do they coordinate attacks and stuff like that, and nobody can figure out until the Alan Turing is a mathematician in England at the time, and he devised a way. So if you're ever interested, watch the movie called Limitation Game. I think called Limitation Game. It's very, very, very interesting that mathematician is actually the most creative. I think for me, math is probably the most creative subject compared to any other subject. The other subject is something that you can grasp, but math you had to think of something, which is like this, and this is one